The data that you work with, that really determines the quality of your model. Big motivation behind TXT360 was how can we take the data that everybody's using and make it easier to use and effectively create better models that are cheaper to train.
Welcome to episode 26 of Tool Use, the weekly conversation about helpful AI tools that you can use today, brought to you by Enetic. I'm Mike Bird, along with Ty Fierro, and this week we're talking about open source datasets. We're joined by Victor Miller, a contributor at LLM360, the team that brought you TXT360, a 15 trillion token dataset. Victor, welcome to Tool Use.
Hi, Mike. Thanks for having me.
We're super happy to have you here, and I think we'll kick it off with the question we ask everybody, but I'm kind of curious how you got into AI and what got you interested in the space and kind of what you're doing.
I kind of had like a good rambling ascent into the space. So basically, my background is all business related. So business undergrad, MBA. And so I was always fascinated with what you can do with data and what kinds of tools you can build and software that you can build around it. So about maybe 8 years ago, when the data science craze was really just getting kicked off, started getting into that, realized that was super fascinating to me. And then basically got through a couple different jobs and networks. Started working at Petrum, which was a AI-focused company. And then that got me into LM360 with a lot of the Petrum folks as being core contributors there. So it's really been a kind of a step-by-step process.
Perfect, man.
Yeah.
And I saw you were one of the contributing authors on the paper Towards Best Practices for Open Datasets and LM Training.
Yeah.
Were you focused mostly on data, or like what parts of AI did you kind of like transition into?
Yeah. So I was really on the product side. So that was being able to go, which I've always been fascinated with because you really get to do the full spectrum of work. So getting to understand, from start to finish, what does the technical process look like? But then also, how is this going to be used out in the world by other people? So looking at from the pre-training sides, especially like the data that you work with, that really determines the quality of your model. And so that's where there was, big motivation behind TXT360 was how can we take the data that everybody's using and make it easier to use and effectively create better models that are cheaper to train.
Fascinating. Okay, I'm kind of curious if you can explain to us like what a data set really is for LLM training and kind of like what makes a good data set, because I know there's a lot of different types of data sets out there and some are better than others, but yep. I'm kind of just curious what quality looks like in there.
Yeah, and that's a great question because that is typically still being defined as what does a high quality piece of data look like. So if we go back to the beginning of, and I'll say beginning, but if we go back, 2 years to what LLM training looked like at the time, people were scraping the internet. And so the kinds of data that you were looking at was Common Crawl. So Common Crawl, if you're not familiar, they have a web scraper that goes out and basically documents the entire internet. You can opt out of it if you want to on your website, but otherwise their data scraping goes back to 2014. So they have terabytes and terabytes of great web scrape data. So that was a common data, and it's open source. And so that was a common data set that people were using. And then people were dependent on the type of downstream task you want your model to be good at. You'll look at specific data sets such as like Wikipedia. That's really good for general knowledge if you want it to continue to be like a useful kind of like chat model or a co-pilot for somebody. But then you might do free law if you want it to have a legal knowledge. You might download like PubMed Central or any of the open archives from the National Health Institute, different types of medical data, archives, bioarchive, etc. So then you will start to, the model will be able to develop capabilities in each of those spaces as you feed it more knowledge specific to the kinds of data that it represents.
Excellent. So I guess to bring it to like the application layer, if say we set up a little app, basic chatbot, storing conversations that users have with it, if I just store all of that in a JSON-L file and just have the conversation back and forth, is that going to be something that's valuable towards a data set, or does it need additional structure to be processed through something like that?
So when you do the actual processing of the data, then you will set it up because data has to go through like a specific tokenizer, whatever tokenizer you're going to be using, and you want to put annotations around the data as well. So that's probably the most important part of like a chat data set. And there's a number of really good chat data sets that are out there. And Hugging Face is the best place to find any open source data for the most part. They do a great job of providing that as a free resource for the community. But yeah, annotations to explain like what is happening, and then being able to like dependent on the downstream effect that you're looking for. If it's just chat, then having user one, user two, simple annotations like that. But if you were looking at like stream of consciousness, chain of thought type data sets that are becoming extremely popular as they've proven to be the way that I guess kind of like the way to unlock LLM's ability to think. And so that you'd want to, annotate each step that, you're taking versus what the model is taking, and be able to then have the model repeat that, in a fashion like what the LLMs are trained to do.
Interesting. I've heard this, I've heard the term like, data is the new oil, and all these big companies have these giant data sets that are all proprietary that kind of make up their secret sauce. But it seems like there's been an explosion of open source data sets. And I'm kind of curious, like what makes open source data sets so important? Like why is open source important? Kind of even going to a philosophical level to some degree of like why open source? Why is this so important for us in this day and age?
Yeah. And that's a great question. So when we look at open source AI, that going back to like the llama models and what now are really the open weight models is what they're commonly referred to. There was a challenge in the community because when you look at traditional open source and when you look at an open weight model, they didn't really match up. But at the same time, the models were free. They were readily available for distribution. You could use them without having to ask permission. And that's when the Open Source Institute started to create what does a definition for open source AI look like? And they released, I believe, their first complete open source AI definition in October 2024. And the important pieces of that is that data is either fully released or there is enough information about the training data that you have included or trained the model on for somebody else to replicate it. Then the other is the code that you use to train the model. And then if there are other pieces that are important, such as checkmark or checkpoints that you might have picked up on, branches that you might have done, but basically being able to help anybody recreate the model is the goal of what that open source AI definition looks like. And it's a very long, very good definition. The Open Source Institute spent a lot of time. I think they spent over 2 years working like with workshops, talking to a lot of people. LM360 definitely contributed where we could. And so in the end, there's a really strong definition out there for what open source AI looks like. And so to kind of fully answer your question on why does it matter is when we look at compute and computing over the last, 50, 60 years, like open source has been a way for the community to advance without, competing commercial interests. So when you look at, operating systems, right? So we've got two winners with Mac and Microsoft, and then you have Linux. And so the best supercomputers in the world all run on Linux operating systems because they allow that level of configurability to maximize whatever downstream use case you are actually working on. So when we apply that same paradigm to language models, we want to have that same ability where we have control over the systems, we have an understanding of what goes into the system and how we can tune it to meet our exact needs without having to potentially worry about or be constrained by what somebody else's goals are.
Yeah, and I've been a big advocate, Ty, as well, of open source for a while now. And when you get the big llama releases, it's great for the industry being able to have these models to play with, fine-tune with, implement. But as you alluded to, when you're unable to reproduce from scratch, you don't really know what it's trained on. There's this still mystery behind this black box behind it that you really can't fully trust. So I know there's techniques to try to fine tune it to like try to take out different things like censorship or whatnot, but still a lot of work to be done there. One of the big things that's been in the news lately is DeepSeek, which is their R1 model. A lot of its brain is open source, but clearly not because they're not releasing the data, whether it's been trained on OpenAI distillation or whatever the theory is. But what are your thoughts on DeepSeek R1?
Yeah. So, generally what I've heard is that it's a great model, that it's useful. And that's I think the only thing that matters when it comes to open source models and open weights models is do they meet end user needs? And from what I've heard, it does. And there are certain areas that it might excel in, but I've also seen people are concerned about certain censorship, which is definitely a piece of why open source models and open weight models, big differentiation there, because you'd be able, if it was a fully open source model, you'd be able to understand what it has been fine-tuned on to not answer. And same with when we look at the evaluations. So when a model is released, everybody goes and looks at certain evaluation scores. And that's kind of our gut check on how good is this model? How is this model going to actually advance what we're doing? But if we don't have the data that it's trained on, we don't know whether it's been trained on those benchmarks, because all of those benchmarks are open and available for anybody. And so there is the, not to say that anybody is cheating, but without being able to prove that you're not, it's always a question on, is this model actually as good as it's reported to be?
Wow, yeah, it's actually a really good point. I like that you brought up Linux, and like Linux and the GNU project was like kind of kicked off this open source movement in a big way. And to some extent, I feel like Linux has won to the extent. I mean, like a lot of our personal computers are Mac and Windows, whatever else, but pretty much every server on the planet is Linux, and Linux is just used in such incredible ways. So it feels like, in some extent, like computing open source has won to an extent, and so like that was a big deal. Meta doing their Llama models was like a huge moment for open source AI and how that was a thing. But they clearly weren't winning necessarily. OpenAI's models were better, whatever else. DeepSeek doing this open source, getting really close to what OpenAI has. It feels like we're trending towards open source almost winning here. Do you think open source can win here? I mean, it's kind of a weird question, but it feels like we're gaining so much momentum in the open source AI community.
So I'm not sure if winning is the right way to think about it. But open source keeping parity with closed source or commercial options, that is something that I think benefits the world. And that's what we have been able to see. Because on the flip side of that, what closed source models are doing is extremely valuable, right? Like you can, with a simple API call, you can access some of the best technology that exists for relatively low amount of money, in some case, pennies. And so that's something where I consider that as for the general ecosystem, that's a win, having access to something that's powerful, or that is that powerful. But at the same time, you still want to have a complete option for yourself if that's the right choice. And that's where open source and having parity with the closed source models is extremely important, and extremely important for the rest of the ecosystem to survive and thrive.
Before we started recording, you mentioned a couple open source models that have come out lately. Do you want to share them with the audience?
Yeah. So with DeepSeek, as we had mentioned, DeepSeek is fascinating what you're able to do with $5 million. But then we saw out of Berkeley the Sky T1 model, which they believe they trained or they fine-tuned for $450. And last week we saw the S1 model out of Stanford that trained for $50. So what both of those papers were able to show was that you're able to create a model that significantly improved upon the base model without much money by applying pretty simple techniques with tracing and kind of chain of thought, chain of consciousness approaches for language models to check themselves before they actually answer.
I love this kind of like metaphor. I think it was OpenAI that said this, but it was something along the lines of just like teaching LLMs to think before they speak and how powerful that actually is. Mm-hmm. Okay, I'm also kind of curious too. So I have a biology background. I actually graduated with a microbiology degree in college and then transitioned into tech, weirdly enough. But I love biology, and I'm so excited for some of these like open source bio models that are coming out. And I know you've done some things with like cancer and LLMs before. I'm kind of curious what your findings are in the bio LLM space and kind of where that's headed.
So the earlier this year, so I guess about a month ago, researchers out of USC and Prime Intellect, they had partnered with the Nucleic Acid Observatory to create a metagenomic foundation model. And so to break that down into simple terms, metagenomics is looking at different kinds of genomes. So you take the human genome, which is your DNA, and then combining that with bacteria, fungus, and virus DNA. And so what you're able to do from that is combining that into a foundation model is really, really simple classification based on different types of DNA sequences. So the original use case that the model was built on was pandemic monitoring. So when you look at wastewater analysis, that was, going back to COVID, that was how, cities, public institutions, they were all sampling wastewater to determine whether there was COVID, the COVID virus in there. And that was, we look back, November 2019, that was, when it first started showing up. And the problem with novel virus detection is you don't have a database read for it. So when we're looking for other types of bacteria or viruses, we're able to look those up and say, yes, this is a match. But when we don't have that, so something like a novel virus like COVID, what do you do? And so that was the impetus behind the MetaGene model was, okay, can we apply the same type of generalization ability that we see with language models with text, but using a foundation model that's trained on different metagenomic sequences to potentially identify and flag, novel pathogens that should warrant further investigation.
That's so cool. That's so cool. I nerd out about this stuff. I actually worked in a public health lab to where we were doing some of this like monitoring, environmental monitoring for particular bacterias and viruses and things. And it was a super exciting, fun job, but it was very manual and it felt almost archaic to some extent. It was so manual and there were so many like very labor intensive tasks. And so I'm so excited for a world where LLMs and AI and technology in general, even robotics too, I think is going to be huge for these types of things. Like I'm really excited for that. And I think of Brian Johnson and his whole like don't die mentality because I don't know, I feel like in the next 10, 20 years, there might be some serious breakthroughs in health and science that kind of push all of humanity forward. And so I'm super excited for it. And I'm curious where the biggest gains will be in these places. So
agreed. Yeah. Some of the interesting use cases that people had talked about using the MetaGene 1 model for was in the public health space. And so, public health departments, they'll sample wastewater to understand what the health of a current population looks like. Same with like military bases, things like that. But one of the public health departments that I heard about, what they were interested in was looking for illicit drugs like a fentanyl, and understanding where there was higher concentrations of fentanyl in their water system, and then using that to target resources for drug prevention, things like that. So they were able to get a much better idea of where they should be focusing their efforts versus taking a broad spectrum approach. So applications like that, where we can really bring about potentially a better world at a very high level, are extremely fascinating.
Yeah, I love that. One of the big drivers for me is the medical tech advancements and being able to make everyone get better outcomes from this. One thing that I think this raises is the need for bridges or just general connections between the people who are implementing the tech and building it and advancing it versus other industries which have yet to be able to implement these type of advances. Because, for example, wastewater monitoring didn't immediately strike me as a novel use for AI, but it will have outsized impact just because of the broad nature of it. What do you recommend, or any playbook or general advice for people who are looking to get into AI who don't have that technical background, but they understand that their focus, their specialty in life could benefit from AI, and they just want to try to bridge that gap?
Yeah. So there are a couple ideas that come to mind. First is, if you have what you'd call domain expertise. So if you worked in the public health sector or in, wastewater analysis, and it was something that was interesting to you, when you hear about those things, there's usually papers that are accompanied with them. Pretty much every academic, you can find their emails. And that is something that I don't think enough people utilize, is that the researchers that are building these new types of technology, they want them used. They build them and they do it in an open fashion, so that way they can have positive impacts. So if you have questions, then those are great people to reach out to. But also, from the higher level, is just thinking about, if you had a magic wand and you got to solve a problem that you have today, can AI do that? That's probably where I would start.
With the whole reading papers thing, I think some papers are a little bit intimidating because there's so much you know, you see these crazy equations on how they're, you know, whatever they're doing for these model things.
Yeah.
But something that I've done it kind of recently, embarrassingly almost, is like if I'm too intimidated by a paper to read it, I'll just throw it into Claude or ChatGPT and just be like, you know what? Can you? I'm like, I 5th grade level, just dumb this down, and I've been some fascinating learnings out of that. And so I think that some of these like scientific papers feel almost out of reach for a lot of people because they're almost too intensely written. So I feel like using these AI tools like ChatGPT and Claude or whatever else are just great for distilling this information down. So I hope more people use tools like that to get more information.
Yeah. And thanks for mentioning that, because that's ChatGPT, depending on whichever model you use, especially like the very good reasoning models, giving them really complex information and having them work through it is absolutely amazing. So one, from understanding, but then also just wondering what's out there. So if you are in a certain sector, you're not sure, can AI help with this? Asking ChatGPT, you know, if you were this person with this problem, how could, or what could some potential AI applications be to solve it? And watching ChatGPT work and really having it kind of be your brainstorm buddy. That's a fantastic use case.
When you go through your projects or day-to-day life outside of ChatGPT, do you use any AI tools, or is that the central hub of your AI exposure?
That's a good question. That's typically where I will start. And let me think. So for meeting transcription, Otter is probably my favorite. I haven't tried many other ones, so a little bit of bias there. But I think
there's this cool thing called Whisperbox you might want to check out.
Okay.
It's a tool we made a couple of weeks ago. Yeah.
Okay.
A little open source one. But
Okay.
yeah,
Very cool.
being
Yeah.
transcriber's cool.
We've actually been noticing that a lot.
Yeah.
Programmers will use Cursor, Claude. We use Super Whisper as a transcription tool, but there really is a disconnect between all the little experiments people are conducting and implementing into day-to-day life, similar to how we were talking about getting AI applied to different industries. So I guess, you know, we didn't plan this ahead of time, but if you were to have a magic wand for your day-to-day life, what type of AI tools would you hope exist, or at least improve to a level that they'd provide real value to you?
Yeah. So that's where I think the concept of agents are fascinating and what they will be able to do. So that's something I'm really interested. I think we're definitely in the first inning of what agent frameworks look like and how successful they are. I think that there will be, purpose-built agents will probably be, the first step, and then you'll move into a more general agent. But, having the ability, especially with like voice and different types of human interactions. So I think that the way that we interact with the world through our browsers and through text is a bit limiting. So being able to expand that is going to be interesting. But then getting, an agent to be able to perform the kinds of tasks that I don't want to do myself, that would be a magic wand. Like being able to order groceries for next week, but know that I want a couple different recipes that I haven't tried before, but all it should take less than 30 minutes to make. And then thinking about how the agents, and you'd mentioned this a little bit before, but how do agent and agent architectures apply to robotics and the types of humanoids that you can see 10-ish years, 5-10-ish years down the road, maybe maybe less, maybe a little bit more, are replacing the kinds of activities that you have to do that you decide are really not value add for you.
Talked about this with my partner before on the topic of humanoid robots. Like if the price point for humanoid robots makes sense, like we have a Roomba and we love it, and like if the price point makes sense, I'll buy a humanoid robot. If I could spend maybe it's $10,000 or $20,000 on a robot, so I don't ever have to do the dishes again, and so it just kind of cleans my house. I think that's incredible, and it's so exciting to me. And I think that's how a lot of like innovation is going to be pushed forward, and how, I don't know, I'm just really excited for that. But what do you think are like the biggest hurdles for robotics right now? Like you say 5 or 10 years, why can't that be 1 or 2 years? Like what's in the biggest thing standing in our way?
I mean, there's a couple big pieces. So if you were to think about allowing a robot into your house, so imagine it's somebody else's robot, not yours. What would you want to guarantee about that robot?
I'm stronger than it.
Right. Okay.
Safety, I guess. Yeah.
Yes. So safety, and the form factor of the robot. So when you look at the humanoids that are being created today, they're massive, and that's also because the use case that they're going to be applied to first is much more on the manufacturing side, and in warehouses, lifting boxes, doing that kind of work. But do you want a 150 kilo robot humanoid walking around in your house? What happens if that falls on you? What happens if that walks into your kid? What happens if that smashes into the wall on accident? Right. So those are the kinds of really simple problems that, and I'm not sure if problem is the right way to talk about it today, but being able to create from the hardware side, hardware that is inexpensive enough that it's at a price point that consumers can afford to purchase it, but then making sure that the policies are safe enough and that there's enough human trust built into basically the operating system or how the robot is going to function, that you can actually control it and make sure it does what you want it to do. So I think that those are some of the non-technical hurdles. I guess the hardware side is probably a technical one, but those are the human factors that I think come into it. And then from the technical side is robotic manipulation and generalization there. So can you, looking at what physical intelligence has been doing and has been promoting the last 6 months, if you're not familiar with them, fantastic. They just partnered with Hugging Face and released their physical intelligence robotic policy model on Hugging Face's Lay Robot, which is their 3D printable arm that they built so people can get into robotics for, I think it's like less than $150. You can 3D print your own arm, buy the motors, and then they've got a whole library on how to control it, how to build different policies and train your own. So those types of applications I think are fascinating. And but when you look at washing the dishes is a great example. So if you go into like what X1 has been doing, and some problems that they have publicly identified is a robot is holding a plate, and when you look at like a robot holding a plate, you're like, okay, cool, that makes sense. And you're using a visual language model to understand that it identified the plate. Now it's got a policy that it's going to rotate the plate to do this. It's going to operate with it. Now it's got water on it, so it'll be a little slippery. It'll be a little bit more slippery. Does that matter on what we do, how we hold it? Okay, but there are certain problems with it going through different phases of light. So you've got one light overhead, and it can't see it, and so it thinks it doesn't have it in its hand or in its gripper, and it drops it. How does it interact with different types of materials? Really going and hammering on the generalization ability. Can it perform at night? Those types of things, are still problems that exist. But it will. I think it comes down to a combination of a data challenge where how can you digitize physical information, and that will be fascinating.
It's actually really interesting. I think you brought up an interesting point about like public acceptance around these things and just kind of like the perception of these, because I think historically humans have a hard time like adapting to new technologies, and there was those people that lit the Waymo on fire in San Francisco, and there's this there will always be groups of people that don't want this type of thing. So I think public perception is kind of a big part of it. I've always wondered too, like if I had a humanoid robot in my house, like what happens when I go to bed? Does it need its own bedroom? Does it kind of just sit in the corner and charge itself? Like then these all these kind of questions are kind of interesting. I don't know, but I think I'm really interested in where robotics goes and kind of tying it back to open source. I wonder if open source, you touched upon this like open source robotic hand. It feels like tech and manufacturing types of things is kind of where private sector has a bit of a advantage there. So I'm wondering how open source, I shouldn't use the word win, but like can open source compete in a realistic way with closed source in the robotics front because of how complex robots are?
Yeah. That's an interesting question. I can really only speculate because one of the challenges is that you will need consistent improvements in open source hardware, and that may happen through 3D printing because that's how a lot of robotic arms are built today that are in the open source space. But when it comes, I think that going back to the digitizing physical information, that's something where language models were able to thrive because they had access to the entire internet. And that's where humanity has been pouring in effort for the last, 15, 20 years, 25, 30 years. So now when you think about, all right, if this language or if the vision language model, imagine that is what is helping to guide and understand, or guide the robot and understand what scenario the robot is in. If we imagine that it is a vision language model, it now has to understand all of these different aspects of the world that it's in, when it may not have that, kind of data. And the generalization ability is definitely going to exist. But if you put it in my room here versus in your room there, or Mike, your room there, how well is it going to be able to understand all the different pieces? And how well is it going to be able to operate? And so that's where I don't know the answer to it. I think it's fascinating. But how do we create that kind of generalist policy that allows the robot to function really in any environment, where for humans, it's kind of seamless. But for somebody who doesn't have that level of cognition, how will it work?
You mentioned Waymo earlier, Ty. My first time in Waymo was with Ty in SF, and when we took a side street, hit the T in the road, and the lights were just yellow and red. There was no green light there, and the machine had no idea what to do. Stuck for a few minutes before support got buzzed, and they kind of gave a little boost to get it started. So the unexpected situations, the corner cases, are really what slows down general adoption. But also, just to touch on the open source aspect of it, there's a company, Comma AI. They make their little driving assistant tool where it kind of hooks into your assisted driving. It's got a camera that points out front, and that relies on OpenPilot, an open source program. Now, they're not looking for full self-driving. They're looking for incrementally making assisted driving better, where it'll be like a cruise control on steroids, where it'll slow down and speed up as need be. And I think having the open source realm kind of like ladder its way up to capabilities is the best way. But I agree with manufacturing, capital intensive things is really tough. But I mean, I got a 3D printer, so I can make a little robot for $100 apparently.
Definitely check out Lay Robot. That is it looks pretty cool. But yeah, to your point about the what happened when Waymo got stuck. So the support that was called in there, they were actually driving the car. That is most likely that they were doing teleoperation there to advance the car from where its confusion point was to a point where it could now automate or operate automatically. And so if you apply that same level of thinking to a robot in your house, are you going to want, your robot is just stuck in the corner and now you have to like push a button and there's going to be somebody else like looking in your house operating it? Or are you going to have to go and, pull up the joystick and start teleoperating it and teach that back? Right. Those are things like in the early adoption phase that you can imagine people will be happy to do that type of work because that you're excited about robots. But for general adoption, is that going to be a acceptable output? And I can imagine that would be a pretty big friction point for a lot of people.
Yeah, really interesting. Okay, I got one last question for you from my end.
Sure.
I'm curious what advice you'd have for like young builder, not even young, but just like builders that are starting out and trying to build applications and work with open source language models. And what's any advice you might have in any aspect for kind of builders trying to get started in this age?
For sure. Is to really focus on problems that people will pay you to solve. That is probably the most important advice. And the only way that you know that is by talking to people. As I feel like everybody, especially when you're trying something new, you automatically go to your comfort zone. So if you are somebody who's more technically inclined, you'll be more inclined to start building something first. Versus if you are somebody who is more of a people person, somebody who likes to go and talk to people, they will, they'll probably go talk to people first. And so really focusing that the best feedback that you can get is hearing no, especially right away, because that will save you tons of time. If you're putting your own money into it, that's just sunk cost. But the time is the most valuable thing that you have, especially if you want to build something new. So focusing on getting feedback as quickly as possible with new ideas, but also focusing on stuff that you're interested in. If you think that whatever, that there's a problem in the world that needs to be solved, you will hear no a ton. And so keep working on it, because there's probably something where if you work enough on it, you'll be able to uncover it.
Words of wisdom. I love it. And last one for me, that's great for the doing. What about the learning? If someone wants to start diving in and reading these papers, do you have ways that you discover it? Are there different channels you get your AI news from? Like, how do you learn AI?
Yeah, so learning AI, I have found, Hacker News is a terrific place. Checking that out once a day, once a week, depending on how much time you have. That's a great source, especially starting out, because you get a big draw from a lot of different sources. Then, diving in, like one of the things I look at is researchers, so that I follow certain researchers either on Twitter. Twitter's a great place. People still announce things there, or X. I know people are moving over to Blue Sky as well. So I know, Twitter, Blue Sky, social channels like that, LinkedIn. There's not so much on the ML research side on LinkedIn, but you will get some stuff every so often. But the most important piece is if you're trying to get into reading the papers and like understanding that level, it's going to be an uphill battle. And so finding the people and the writing styles that make the most sense to you is definitely something that has helped me out, because there are some writers that you end up reading like their 20-page blog and you didn't even realize you spent an hour on it because it's just pulled you in. And there's some, you get halfway through the first paragraph and your head's already spinning. So finding, sources that are accessible to you and using your favorite LLM to simplify it for you.
Well, Victor, it's been a pleasure having you on. Before we let you go, is there anything you'd like the audience to know?
So I want to say, Mike and I got to meet through the Mozilla AI Discord, and Matt Cool over at Mozilla. So if there are other folks that are interested in building AI, building open source AI, or already doing it, definitely check out that Discord. That's a great place to be.
My favorite Discord server to hang out at. Yeah. Awesome.
Well,
all right.
Thanks so much for being on, man. Appreciate it.
Definitely.
I learned a lot today, and I have a lot to think about with robots. This is kind of a new space for me. LLMs felt like alien technology when it first came out. Now I'm kind of in that headspace for robots, so I have some reading to do.
Yeah, that's the saying out there now is that robots are the ultimate application layer for AI. Yeah, and I think that's where AI goes. The next 10 years. Both vision and action, combining those language models. They've I don't know if you say that they've peaked, but like what GPT-4 was when it first came out, right? That's totally obsolete. Now you're getting these reasoning models that are able to do things, looking at what actions those, or reasoning into action. That'll be your agent, and then applying that to a physical policy into a robot. I think that's my bullet point version of what the future looks like.
Yep. Let's embody it.
Right. Yeah. Still a lot of papering over there, but yeah, we'll see.
All right.
Cool.
We'll talk to you soon.
Yeah. Sounds good. Thanks, guys.
See ya.